Hey guys, Shay Matthew Kenisher here with Shay 3.0. I want to make a quick video about algorithms. Specifically, what is an algorithm? If you dig into this, it's kind of hard to find an answer. You might get different definitions. And I was doing a bit of research on this morning actually. And what I found is there is some research that goes back, at least from what I saw, to the 70s. Maybe people were thinking about this before. But an algorithm is essentially logic plus control. So logic is going to be the structure, as it were, of the algorithm itself, right? Just like classical logic, predicate logic, right? Like just in English, like logic that you would learn in philosophy, intro to logic. That's the structure of the algorithm. And then the control part is essentially the process of what are you going to do with it? What are you going to make it do? Are you going to do top down or bottom up? Are you going to go left or right, as it were? Not necessarily literally left versus right, but that kind of abstraction of process and what are you going to make happen. It's another way to look at it is algorithms are controlled deduction. If you have just strictly logical deduction, then algorithms are instantiations of that with a certain control process in it. And being that algorithms essentially make up are a core part of computer science. I haven't gotten into the foundations of computationalism enough to really say confidently that algorithms are the foundations of computer science, but obviously they're a core part of it. But they're controlled deduction, they're logic plus control. And one of the reasons why I talk about this is because I've wondered personally if what's the relationship between logic and algorithms, or even algebra, which is related but a different thing because it's a whole field and has its own dynamics and philosophical underpinnings and so forth. But the roots are obviously the same. The general like face value of them are similar, logic and algebra, right? They kind of have their own aesthetic and their own type of knowledge, if you will, that contrast, at least in my perception, to other branches of mathematics, for example, like geometry, which is just clearly about space, or topology, which is kind of an extension or an outgrowth, or how should you say it, of an extension of geometry, basically. And number theory and arithmetic would just have to do with numbers, as it were. But algorithms and algebra and logic have a sort of different kind of thing about them that is not about anything in particular in the way that those other branches of mathematics are. So there's a different qualitative dimension to them, if you will. And I feel like that's partially their power, and why in computation and what became computer science, there's been so much potential to actually build on top of the natural science engineering knowledge that we've developed, especially like in electrical engineering and electronics and physics, to build physical computers. The theory of algorithms and logic got this synergy with physical computers in the 20th century that just kind of blew up that branch of knowledge and practice in a way that also calculus, for example, not to digress back on that, but calculus is essentially about like change over time. Like calculus is obviously critical for physics and engineering, classical forms of engineering, not software engineering. But yeah, so there's something unique about algorithms and logic and so forth. So algorithms, logic plus control, that was kind of the idea that I wanted to put out there. So if you have any ideas about algorithms, or the way that you look at them and the way that they relate to computer science and or mathematics, or just knowledge in general, I would love to hear about it. leave it in the comments. If you like this video, please click the like button, the thumbs up, and please subscribe to my channel, all about software and development and computer science topics. So, thanks so much for watching. This is Shay 3.0 signing out.